Hello friends, today let us see about some common mistake while answering the differences between an synchronous and asynchronous communication. So people will commonly make mistake while answering these type of questions. The common mistake between while answering the synchronous and asynchronous is many people will say that if the clock is present, it is called as an synchronous communication. If the clock is absent, it is an asynchronous communication. So if we go deeper to it, what is clock present means, the people will unable to answer these kinds of questions. So today let us see about how exactly the difference between an synchronous and an asynchronous communication. So first let me brief about this asynchronous communication. So this is an transmitter receiver of one of an asynchronous one, and this is an transmitter and receiver of another asynchronous receiver. So these type of an receivers will be having an transmitter and an receivers. So an transmitter of one of the communication has been connected to an receiver of another transmitter. The transmitter of another one is going to be get connected to a receiver as shown in this figure. So another thing is there is a common clock for activating both transmitter and receiver. So this is present for both synchronous and asynchronous communication. So this common clock actually means that, see, consider the example of dumping a program from your PC to your any of an ARM kit, or it can be an 8051 or an Arduino. So during these type of communication, an asynchronous communication is going to happen. So in order to have an communication between transmitter and an receivers, so your transmitter and receiver should be in an on state. So your PC should also be in an on state, and the receiver, that is your ARM kit or an 8051 kit, should also be in an on state. So this common clock says that PC is going to be running with an sum of the hertz, consider as an 12 megahertz. So your ARM kit will be running at an same 12 megahertz. So this is the common clock for activating both transmitter and receiver. For transmitter is your PC and your receiver is your microcontroller. It can be an 8051, it can be an ARM microcontroller or anything, but the common here is 12 megahertz clock frequency. So it can be an synchronous one and an asynchronous one. We will be having an common clock. So this is an arrangement for an asynchronous one. So it is having only transmitter and receiver. So transmitter of this will be zigzagly connected to the receiver, and this one transmitter has been zigzagly connected to the receiver in this fashion. So this is an asynchronous communication. It is having an common clock activation 12 megahertz for PC and your ARM microcontroller, or it can be an 8051 or it can be an Arduino. So let us see an synchronous one here. So this is an synchronous transmitter and a receiver. Here also we will be having an common clock for activation of transmitter and receiver. So here one difference here is it is having an clock signals. So these clock signals are going to be get connected to an receivers. First, clock signals will be synchronous between transmitter and receivers. So for every change in an clock, the data is going to be get shifted by 1 bit. Here we are going to make use of an shift registers. So this shift registers value is going to be changed for rising edge of an clock or an falling edge of an clock. So it is based on the initialization, how you are going to initialize the clock. If you are going to make a positive change of an clock, then the data is going to change for positive clock cycles. If the data is going to be set for changing for negative clock cycles, so it is based on the synchronizations or based on the default settings what you are going to be performed with. So here you are having a clock. For each clock signals, the data is going to be get changed. So before transmitting any of an data, the clock is going to be get synchronized between transmitter and receiver. So for every clock cycle, the data is going to be get shifted by 1 bit in your shift register. So here also we'll be having a common clock. So synchronous communication is going to happen. Synchronous communication is going to happen only in your on-chip communication. So your on-chip communication means the peripherals which have been obtained at your on-chip. Oh, sorry for the interruption. So the communication which is going to happen at an on-chip. So during those type of communication, you are going to make use of an synchronous communication. So whenever you are dumping any of the codes or whenever you are making an long distance communication, you usually prefer asynchronous based communication. So this is what the synchronous definition and an asynchronous definition. So let me tell the one difference between an synchronous and an asynchronous one. So by seeing this figure, you can easily make what is the difference between an synchronous and an asynchronous communication. So as the basic answer, what you will be saying that clock is present and clock is absent. So that is what you need to prefine, that is here data is going to change with the clock cycles. Data is going to change with the clock cycles. Here for transferring and data, there is no need of a clock. But whereas in an synchronous, the data is going to change with the clock cycles. If the clock cycle is changed, the data is shifted by 1 bit to a shift register. But one thing is common. The common clock is present for activating both transmitter and receiver. It can be an synchronous communication or it can be an asynchronous communication. We will be having a common clock for activating both transmitter and receiver. So we will be having common clock for activating both transmitter and receiver. So here also we will be having a common clock for activating transmitter and receiver. So the one difference here is data is going to be pushed along with the clock. Here data is, there is no clock for transferring any of the data in an asynchronous communication. But for activating both transmitter and receiver, we will be having a common clock here. So for example, it can be an 12 megahertz. So thank you. Subscribe more for these kinds of videos. Please subscribe, like, share.